Beside the raw signal, we also have 3 other figures for the force plate data. To make these figures visible, we need to do force plate calibration. For calibrating the force plate, we use a weight of 25 kilograms in a vertical direction, and we also use this frame with a weight of approximately 5 kilograms for calibrating the force plate in horizontal direction. Let's do the calibration of the force platform. For this, let's go back to FEWM software and go to the analog input. We start the force plate 1. We go to the force plate 1 calibration, and we do the reset of the amplifier before each calibration trial. Therefore, I do the reset, and then here I click on the start button. It takes 5 seconds, and we choose the null, and there is no weight on the force plate, so it's 0 kilograms, and we select OK. Now let's do the calibration of the force plate in vertical or Z direction. For this, we need to do reset of the amplifier first, and we need to put the weight on the force plate. And the exact weight is written on this. So we need to include this number in the system. We click the start button. We choose the Z direction, and we write the exact number of the weight here. And we press OK. Now let's do the calibration of the force platform in X direction. So we need to prepare such a setup beforehand. The frame that we want to use is connected to the weight of the 25 kilogram using this rope. As you can see, the rope is not completely horizontal. So with this measure, we want to know the height of the rope here, which should be equal the height of the rope here. So for this, we need to bring this slightly up. Yeah. After adjusting the height of the rope, we need to take the weight out of the force plate. For this, I will bring this a bit forward so the rope is loosened already. I take this out of the force platform. I'm going to do the reset of the amplifier. I bring the weight back to the force plate. Make sure the rope goes exactly in the middle of this steel item, and I attach everything back. So I will bring this frame back in a way that the weight is hanging in the air. Make sure that the line of this line, the direction of the rope is parallel with the direction of the edge of this force. So for this, I need to bring slightly this to the left, and remember that the exact number of the weight is written on this weight. So we need to import this number into the system. Let's click on the start button, wait for 5 seconds. Now we need to choose the X direction and import the number of 4.99, which is written on the weight. Let's click on the OK, and we have done the calibration of the force plate in X direction. For calibrating the force plate in Y direction, we have to shift the frame in a way that the rope applies the force in Y direction. So we lose it. So now the frame applies the force in Y direction. Again, we need to loosen the rope, take the rope out of the weight. We need to take the weight out and reset the amplifier. I need to bring the weight back. I need to attach everything again. And I need to bring this back, the frame back, so the weight is hanged on there. Again, make sure that the line of the rope is parallel with the line of the edge of the force plate. You have to go back to the system, click on the start button, and choose the Y direction, and the weight is similar as before, 4.999 kilograms, and we press OK. Now we press the quit button, and to calculate the gauge factors, we press the OK button. Here are our gauge factors, and these numbers shouldn't deviate more than 3% of our standard calibration factors. In this case, since we have used the second amplifier sensitivity, the number should be compared with the second range. Now to verify our calibration, we want to do the very simple measurement. I'm gonna put the 25 kilograms on the force plate and check the data. So we know that the 25 kilograms is equal to 245 Newton. I start data collection. I put the 25 kilograms on the force plate. Get out. Let's check the data. I stop the data collection, and let's zoom in the data. As you can see, the data is around 245 Newton. So our calibration went well. Last thing to check is the force plate drift. If the amplifier are warm up properly, the drift should be less than 3 Newtons in 100 seconds. So for this, I'm gonna do a simple measurement. There is nothing on the force plate. So we go to experiment, measurement, and we do 100 seconds. I start data collection. As you can see here, the drift stays below 3 newtons over 100 seconds. So the calibration went well. We verified that the 25 kilograms is equal to 245 newton in the data. And we also show that the drift didn't deviate more than 3 newtons. So everything went well. We can start the data collection using the force plate.